Welcome to Brain Vision.
Okay, question 62. Daring Darless wishes to cross the Grand Canyon of the Snake River by being shot from a cannon. She wishes to be launched at 60 degrees relative to the horizontal so she can spend more time in the air waving to the crowd. With what speed must she be launched to cross the 520-meter gap? So the setup for this question is basically we have a gap we need to bridge, and we're being launched at 60 degrees, just about squeeze that in there, at some unknown velocity, which I'll call u0. So let's get some idea of what we're working on in x and y, just defining the y as vertical and the x as horizontal. And so I always write out suvet, and it's just a shorthand notation for the s being the distance through which we're talking about traveling. Of course, that's 520 meters in x and 0 meters in y, because we do want to land, so we have gone no distance. For our u is our initial velocity, and so hence we're going to call this u0 cosine of 60. And there is no horizontal acceleration, so of course u0 cosine of 60 also works for our final velocity. As we said, there's no acceleration in the x direction, leaving us with t as just t. And in the y direction, we have the distance traveled is 0, as we said, because there's no height change. We land at the same level we take off from. Our initial velocity is u0 sine of 60. Our final velocity, well, through symmetry, we can see that this is a parabolic path. And so we can actually say, through symmetry, we can shortcut this answer and say, if we were going up at a certain velocity, we are coming down at that same velocity, minus u0 sine 60. With, of course, our acceleration being g, and we'll stick a minus on there as well, because it's in a negative direction, and our time is t. So let's see what equations we can get from this. Well, from y, from the vertical direction, we can certainly work out that our final velocity is equal to our initial velocity plus some acceleration multiplied by time. And so we're going to write out what this means for us. It means that our final velocity, negative u0 sine 60, is equal to u0 sine 60 summed with minus gt, because of course g is negative. And let's just rearrange this whole thing for t. So we bring the u0 sine 60 from the left-hand side and take the gt onto the left-hand side, leaving us with gt here is equal to 2 u0 sine 60. And therefore t itself is equal to 2 u0 sine of 60 over g. Okay, perfect. And then for our x direction, we can realize that we have simply the distance we need to travel. S is equal to our initial velocity or our final velocity. It's whatever velocity we want multiplied by t, because there's no acceleration. And so 520 is equal to u0 cosine 60 multiplied by t. And we rearrange for t, 520 over u0 cosine of 60, and we get t here as well. So what do we do now? Well, we realize that we have an equation with t as the subject here and t as the subject here. So why not equate those two things? 520 divided by u0 cosine of 60 is equal to 2 u0 sine of 60 over g. And we're going to have to move the page a little bit. So let's just scroll down a little bit here and take from here. And we'll simply rearrange for u0, making u0 the subject. So of course we bring our u0 up, and let's take our trig term down, our trigonometric term down. I'm not going to do everything at once here, just take it a little bit gently, leaving sine 60, cosine 60 on the bottom of this fraction. And that's going to be equal to 2u0 squared divided by g, of course. And then we can fulfill the rest of this by saying, well, u0 squared is equal to 520 multiplied by g divided by 2 multiplied by the sine of 60 and the cosine of 60. Which means from this that u0 itself is equal to the square root of all of this, and frankly it gets a little bit dull just to write it out. I understand this is the problem with some questions like this, but writing it out does help with the practice side. So 2 cosine 60, sine 60 on the bottom, 520g on the top. Square root the whole thing and we get an answer for u0, and we find our answer is 76.7 meters per second, of course taking g to be 9.8. And that's how to solve question 62. It's a bit involved, but really easy once you get through it.